Good day everyone. So in today's video we are going to be talking about fluids. So what exactly is a fluid? Is it only water, or there are also some kinds of fluid? So talking about fluids, fluid is anything that can deform or anything that can flow, provided that there is a force. In engineering we call it shear stress, but let's stick to force here. So anything that can flow under the application of force is called a fluid. Alright, so anything that can flow is called a fluid. Mainly we have two types of fluid. We have liquids and we have gases. Alright, they are called fluids. Alright, so let's talk about some key properties that you should know. One of the most important property you must know is pressure. Pressure is one of the properties you should know, and pressure P is force over area. Pressure is force over area. Another key property you should know is your density. And density, using the Greek symbol rho, is equal to mass over volume. Alright, so density is equal to mass over volume. Another property you should know is viscosity. We call it mu, like this. We're not going to be talking intensively on it in this video, but just know that is the resistance. So viscosity is the internal resistance to the flow of these fluids. The internal resistance. What resists? Friction resists one body sliding over another in mechanics. But in fluids, what resists the flow of fluid is called viscosity, and is denoted as mu. Alright guys, so let's talk about pressure in fluid. Let's assume we have a cylinder. Let's say we have a cylinder here, and we have a cylinder like this. We have this cylinder to be having an height h and a radius r, and we want to determine the pressure here. As we already know, pressure is force over the area. Alright, so let's talk about pressure in fluids. Let's say we have a cylinder like this having a height h and we have a radius r. Now, how can you determine the pressure? We know that pressure is force over area. And if you remember from this equation, we say density is mass over volume. It means our mass is density multiplied by volume, right? Good. Alright. And we know that volume is what? Area times the height. So it means that our mass is equal to density area height. So it means that our pressure will become this. But how? Let's stay with me. Pressure is force over area. What is our force? Our force is mass times acceleration. We are going to say due to gravity all over area. And what is our mass? Our mass is density times area times height. So we are going to put density times area times the height, G all over E. So this will go with this. So we are now having P is equal to rho G H. So it's rho G H, not so it's H. I'm sorry for that, it's H. So we're having pressure to be equal to rho GH. We call this hydrostatic pressure. Hydrostatic pressure. So this pressure, if you are given a question, you will be able to solve many questions using this equation. Alright, so we're going to solve this question on our screen right now, and let's see how we can apply this formula. But before we do that, you must know that the unit of pressure is Newton per meter square. Another unit of pressure is Pascal. Another unit of pressure is Toll. Another unit, especially the one used in chemistry, is millimeter mercury or centimeter mercury. I believe you understand. Alright, so we're going to be solving some questions using this hydrostatic pressure formula. Now, considering this question on your screen right now, an open tank contains water. A point in the water is located at a depth of 5 cm below. So it means that the height of this container is 5 meters. When you are solving physics problem like this, make sure it's in standard units. Since it's already in standard units, so we are not doing any conversion. Below the surface, given that the density of water is 1,000 kg per meter cube, so our density is 1,000 kg meter per cube, and the acceleration due to gravity is 10 meters. So we are given G normally is 9.81, but now is 10 meter per second square in this question. Now there are 3 questions here. The first question is, state the formula for hydrostatic pressure. It's very easy. That's the formula I told you to memorize. Hydrostatic pressure, P, is equal to rho GH. Number 2, calculate the pressure at the point, that is this point, 5 meters. We just have to, do the math, just compute that. So we're going to have density is 1,000, gravity is 10, height is 5. So this is going to be you type in your calculator, you are going to get 50,000 Newton per meter square or Pascal, because if you type your calculator in very well, this is what you are going to get. This is because 1 Pascal is equal to 1 Newton per meter cube. Now the third question, per meter square, Now the next question is, explain how pressure varies with depth in a fluid. Now imagine if you are going inside a river, you'll be feeling more pressure as you are approaching the bottom. Do you know why? Because the weight of the water is in you. So therefore we can say that pressure increases with depth. Are you with me? So pressure increases with depth. So explain how pressure increases with depth. You say pressure in a fluid increases with depth. Alright. So